a recipe. Okay? And when we double people. Remember, what do we do when we double people?
Like if you had like 20 people, you double it. So it's like 20 plus 20.
Oh, 20 plus 20. So what operation did I use when I doubled?
What?
You are adding
Adding.
You are adding again plus that number.
Okay, sweet. So when I'm asking you to double something, I'm asking you to use the same number and add it over again. Good. Okay, so when we were doubling the recipe, isn't that what we did? We doubled 1 3/4, and then you just added another 1 3/4. Okay? So doubling really means addition. We're doing something twice. Okay? So what's my whole number? 6 is my whole number. What's my fraction? Bailey, what's your whole number? 1. And your fraction? 3/4. What's your denominator? You have lots of them over there. How about this one? Talk to me about this one.
You have 5 holes and then you have 6 out of 10.
So, you completely understand what the mixed number is. So today what we're going to do for today's lesson, I want you to look up here because this is our objective. I want you to be able to identify a mixed number. Did you just identify a mixed number?
Yes, ma'am.
Yes.
Excellent. But now we're going to add mixed numbers with the same denominators. And we're going to use our virtual manipulatives that we worked on the other day. So I went ahead and I made up a problem for you. And this is where these little grids are going to come in handy. I went ahead and made 2 mixed numbers and I added them together. So my first mixed number is 1 3/5. Abby, can you read my second mixed number?
2 wholes and 1/5.
Right, and I would read that 2 1/5. Right, 2 and 1/5. So when I'm adding these two together, so you remember our virtual manipulatives, we were working with a fraction. 2 wholes and 1 more fifth.
You would have 4 holes.
And then for me, I want to add up my holes. That's what I want to start with. So I'm going to count my holes. 1, 2, 3. I have 3 holes.
Is our answer going to get larger?
Maybe not. 3 holes. And then I want to add my fifths. Can you count with me? 1, 2, 3, 4. So I have 4, which is my numerator, and then fifth. So 3 and 4 fifths. 1, 2, 3 and 4 fifths.
Oh, I thought
Now,
was
I want to go to a question box. And I'm going to have somebody pull a question out of the question box in regards to this number. Okay? So let me write this number here for you so everyone can see it. 3 and 4 fifths. It's my question box.
How many slices are there?
Janya, quick question.
the number that makes up our
Ooh, what is the number that makes up our denominator? We're not going to blurt, right? That's one of our vocabulary words this week. Blurting. No blurting. Jasmine. 5. So my denominator is 5. So what number represents 5? What do we say this is? 5. It's 5, but it's the denominator, but it's in fifths. Okay, Desmond. What is the difference? That's okay.
the difference between the 3 and the 4 and 3 4/5.
3 and 4 fifths. So let's see about this. What is the difference between the 3 and the 4? And 3 and 4 fifths? Abby.
So this is 3 holes.
So I have 3 whole groups.
That is a whole, and 4/5 or a fraction doesn't go like more than 1 or more than 2 or more than 3.
So you're telling me that the difference between my 3 and my 4 is the 3 is a whole number.
Yes.
The 4, what do we call this number?
What?
What's this number? Just this number, this top number in my fraction. What's this called?
Numerator.
Numerator. Thank you for helping. It's my numerator. So the difference is this is my whole number. This is my numerator. Abby, Michaela. So what happens when we add, what happens to our denominator when we add like denominators?
It gets bigger.
My denominator gets bigger? Did my denominator get bigger here? I have 1 3/5 and 2 and 1/5. What happened to my denominator?
It got 2 and 1. It got more fraction pieces.
1 3/5 plus 2 1/5. What's my denominator in this fraction right here?
5.
What's my denominator in this fraction here? What's my denominator in my answer?
5.
What happened to my denominator?
Nothing.
Dang, it's the same one. Good job. Way to work through that. Persevere. Planning for St. Patrick's Day party, Mrs. Mangum needs to figure out how much time she would use to prepare everything. If she spends 2 and 2 6 hours working on food preparation and 4 and 3 6 hours cleaning, how long would it take Mrs. Mangum to get ready for the party? What is my question asking you?
We are adding.
How do you know?
Because, how much, you would spend time. That seems like you're trying to add together because you're trying to figure out how much you're spending.
Excellent. So what am I looking at? I'm looking at food prep and I'm looking at cleaning, right? How long it's going to take me to make all the food and how long it's going to take me to clean. So do me a favor, you have sticky notes in front of you, just like I have here. Can you write one of your mixed numbers on your sticky note and put it on your equation? Put your hand on your head. I want you to solve it with your fraction bars, okay?